Hello friends, welcome to class 12 physics chapter number 1st rotational dynamics. Dynamics, the word comes from mechanics. Mechanics is the branch of physics which is divided into two parts, that is statics and kinetics. Statics, that is the study of objects which are at rest. Kinetics, that is the study of objects which are in motion. Kinetics is also divided into two parts, that is kinematics and dynamics. Kinematics, the branch of mechanics that is concerned with the motion of objects without reference to the forces which causes the motion. Dynamics, the branch of mechanics that is concerned with the motion of objects with reference to the forces and their effects on motion. Now, the term rotational, that is rotational motion, is the motion of system of particles that moves around the axis of rotation is called rotational motion. In this chapter, we study the rotational motion of a rigid body. If we consider a single particle on a rigid body, then motion of that single particle is a circular motion in rotational motion. Therefore, circular motion is a motion of a particle along the circumference of circle. Circular motion is divided into two types, that is uniform circular motion and non-uniform circular motion. Uniform circular motion means the motion of a particle along the circumference of circle with constant linear speed or constant angular speed. And non-uniform circular motion means the motion of a particle along the circumference of circle with variable speed. There are some more terms in rotational dynamics: angular displacement, angular velocity, angular acceleration. Angular displacement denoted by using letter theta. Angular displacement is the angle traced by radius vector in the given interval of time. Its SI unit is radian and it has no dimension. Angular velocity, it is denoted by using letter omega. Angular velocity is the rate of change of angular displacement with respect to time. Its SI unit is radian per second and its dimension is m raised to 0, l raised to 0 and t raised to minus 1. Angular acceleration, it is denoted by using letter alpha. Angular acceleration is the rate of change of angular velocity with respect to time. Its SI unit is radian per second square and its dimension is m raised to 0, l raised to 0 and t raised to minus 2. Relation between linear velocity and angular velocity. Linear velocity is the rate of change of linear displacement with respect to time, that is ds by dt. Suppose particle is initially at position A and it goes finally to the position B. Its angular displacement is d theta and its linear displacement is supposed to be ds. Therefore, you know that the formula angle is equal to arc upon radius. Here angle is d theta, arc is ds and radius is r. Therefore, angle is equal to arc upon radius. Therefore, ds is equal to r into d theta. Substitute this value in equation first, the value of ds in it. Therefore, v is equal to r into d theta, that is value of ds, r into d theta upon dt. R is constant, therefore d theta by dt means the rate of change of angular displacement with respect to time, that is angular velocity omega, and therefore v equal to r omega, that is linear velocity, is equal to radius into angular velocity. In vector form, v vector equal to omega vector cross r vector. Relation between linear acceleration and angular acceleration in circular motion, that is in non-uniform circular motion. In non-uniform circular motion, the relation between linear velocity and angular velocity, we know that is v is equal to r omega. In vector form, v vector equal to omega vector cross r vector. A vector, that is total linear acceleration in non-uniform circular motion. Take the derivative of this v with respect to t, we will get acceleration, that is a is equal to dv upon dt, that is d by dt of this phi omega vector cross r vector. If we solve the derivative of this vector, then first term remains as it is, take derivative of second, plus take derivative of first term and then second term remains as it is, that is omega vector cross derivative of second dr vector by dt plus d omega vector by dt cross r vector. Omega vector as it is, derivative of the rate of change of displacement with time, that is called linear velocity, plus the rate of change of angular velocity with time is called angular acceleration, that is omega vector cross v vector plus alpha vector cross r vector. A vector equal to ar vector plus at vector, this ar vector, this is at vector. Ar vector, that is equal to omega vector cross v vector, and at vector, that is alpha vector cross r vector. Ar vector means the radial component of total linear acceleration, and at vector means the tangential component of total linear acceleration. It is also called a centripetal acceleration.